Mercedes-Benz vehicles, and a couple of common issues with the AdBlue systems. Okay, so selective catalyst reduction, or AdBlue, is an active exhaust gas after treatment for ultra-low emission systems and allows emissions to be minimised while enhancing fuel economy. The systems meet the emission standards for EU6 and NAS emission standards. The diesel exhaust fluid, DEF, or brand name AdBlue, is a urea solution which is made up of 32.5% high purity urea and 67.5% deionized water. When this is injected into the exhaust flow, this produces ammonia, which breaks down more than 50% of nitrogen oxides into harmless nitrogen and water in the downstream SCR catalytic converter. The DEF fluid is contained in a separate tank in the vehicle and is conveyed via a feed pump to an AdBlue metering valve or injector into the exhaust, and is injected directly into the exhaust gas flow. The AdBlue solution is topped up during regular servicing and is not categorised as dangerous and is safe to store. Now, just to note, there are different sizes of tanks on Mercedes-Benz vehicles. Now, depending on the size of the tank, the range of AdBlue may be anything between 3,000 miles up to 10,000 miles before it needs refilling. Here's an illustration of the differences between Euro 5 and Euro 6 variations. As you can see on the left, an engine with a higher fuel consumption and lower combustion temperatures produces more particulate matter, DPF, than the NOx. The particulate matter is then cleaned via regeneration of the DPF as normal. On the right-hand side, the engine is more fuel efficient. By increasing combustion temperatures, it uses less fuel and more air in a lean burn strategy. This causes excessive NOx, and therefore AdBlue is injected to reduce the temperatures and to change the harmful NOx into harmless nitrogen and water. And that is the Euro 6 proposition. Here you can see a typical layout of an AdBlue system in a Mercedes, starting with the tank. This is an inbuilt temperature sensor, a heating element, a fill level sensor. There's also a supply line to take AdBlue from the tank via the pump to the injector in the exhaust. There is a pressure sensor in the pressure line going to the injector. This will monitor the delivery pressure from the pump to make sure everything's okay. Then into the exhaust there is an SCR catalyst with NOx sensors either side to monitor NOx emissions. These send the information back to the CDI module, which will send the request to the SCR via CAN, which will adjust the opening duty cycle of the injector accordingly. Here is a graphic illustration of the process and reduction in NOx, leaving harmless nitrogen and water emitting from the tailpipes. This is an illustration of the Mercedes BlueTech design without AdBlue. These vehicles have an NSK storage catalyst, which will store the NOx particles produced during the combustion phase. They are converted into molecular nitrogen, N2, and water, H2O, during the regeneration rich burn phase. A chemical reaction produces ammonia, which is stored in the SCR and is then consumed during lean burn or a high NOx operation. During the lean burn, any nitrogen oxides which cannot be stored in the NSK are converted into molecular nitrogen and water by the SCR using the stored ammonia. Here is the layout of the AdBlue delivery system in the BlueTech with AdBlue. And if you'd like to note there, the temperature sensor in the tank, and when it's monitored and it sees -7 degrees, the AdBlue heating element will be switched on by the SCR control unit. And here is the layout of the Mercedes BlueTech 2 system. On these vehicles, NOx reduction is performed by injecting AdBlue into the system during normal operation. This is monitored by NOx sensors pre and post SCR via the CDI, and the AdBlue is administered via the SCR control module at the request of the CDI. Now, the CDI monitors the SCR operating system. It will register the temperature of the catalytic converter. Once this temperature reaches between 250 and 600 degrees Celsius, it will then instruct the SCR via CAN to inject AdBlue into the exhaust. The CDI will then monitor the NOx pre-SCR and will send the request for the AdBlue injection to the SCR control unit. Then, post-NOx sensor will measure the output from the SCR catalyst during usage and send this info back to the CDI, which will check and adapt accordingly. Note, during the warm-up phase and before the 250-degree threshold, the status of the NOx sensors on a diagnostic tool will show as not operational. Here you can see the two units involved in the SCR, which is the CDI module on the left and the SCR AdBlue control module on the right. The CDI is responsible for the sensors in the exhaust and the DPF and DPF pressure sensors. The SCR is responsible for the actuation of the metering valve, the heating element in the tank, the feed module including the pump, and the temperature and level sensor in the tank. The DPF process in the BlueTech 2 system is monitored by the DPF pressure sensor to calculate the soot load and fill level of the DPF and the temperature sensor of the DPF. This will then calculate the DPF time required and instigate the regeneration phase required to reduce the soot level. Here you can see a picture of the redesign of the SCR. This is fitted to the Mercedes-Benz range with OM 654, 656 and transversely mounted 651 engines. Now, in comparison with previous diesel engines, the after treatment has been completely redesigned. For the components, this means that in addition to the proven diesel oxidization catalytic converter, there is now also a compact unit that comprises of the DPF with the SCR joined onto it. The diesel particulate filter also now performs a functional task in the SCR. Mounting the exhaust gas after treatment components near to the engine is also new. This enables fast heating, ensuring that the diesel oxidization catalytic converter functions effectively even in the low engine temperature range. And there you can see in the picture, A is the diesel oxidization catalytic converter, C are the evaporator plates going into the exhaust, and D is the DPF with the SCR unit combined onto it. Here is an illustration of the SCR emission control technology, showing the storage catalyst and reducing agent combining to reduce nitrogen oxides. Now on this screen here, you will see the early warning system that will come up on the dash of a Mercedes-Benz. This message doesn't always mean there is a fault with the system. It is a level low warning that will typically start at 1,000 miles before empty and will continue to count down to 0. Once topped up to the correct level and the vehicle has been driven, the warning light should go out. Only will it stay on if there is a fault in the AdBlue system, and this could be meaning the AdBlue system is now non-operational due to the fault. Now, the possible issues can be overfilled, so it has been low, somebody's filled it up over the correct level, and now the level sensor cannot calibrate its own level. Incorrect AdBlue or quality of AdBlue. A blocked AdBlue injection nozzle or a defective nozzle, a blocked mixing plate, which can be caused by a dribbling injector in the exhaust, a knock sensor malfunction, or a SCR catalyst malfunction. Once this screen comes up on the vehicle will now not start. It will render the vehicle immobile. The process to reset this is refill the AdBlue to the correct level, reset the calculated fill level in the SCR control unit, reset the warning message in instrument cluster. Now this will be either in the CDI unit or in the SCR AdBlue control unit where supported. If the vehicle or if the sequence is successful, the vehicle should then start and the faults can be extinguished. That brings us to the end of this short webinar. If you have any questions, please type them in and I'll try to answer them. I'd like to thank you for watching this webinar regarding the AdBlue on the Mercedes-Benz also. Damien, no, you cannot perform a hard reset by disconnecting the battery after top up. Only if it needs resetting, you would have to do this via the diagnostic tool. If it's okay and everything's working correctly, then after a drive cycle, it should reset the fault anyway. No problems, Damien. Hi, Andy. Yeah, I'll repeat the reset procedure. Is that for the engine not starting? Okay, so you'll need to refill the AdBlue to the correct level. Then you need to go into the SCR unit and reset the calculated fill level, so recalibrate it. Then you'll need to go into reset of warning message. Now this will be done in adaptions or actuations depending on variant. And this will be in either the CDI unit or the SCR. And it will simply be a tile that says reset of warning message in ICM. If you hit that, that will then clear the engine start not possible fault and should allow the vehicle to start. Hi Zane, I'm not sure if these static notes are available for download. I can speak to Nicola after this. We will send the presentation via PDF, Zane. Hope that's okay. Damien, the system can be overfilled. It can be overfilled if it's filled via a bottle from a petrol station. If it is overfilled, then it's simply a case that you will have to siphon some of the level out, look at the level as it states on the diagnostic tool, then add slightly until it becomes up to the correct level. It will all depend on the actual capacity of the AdBlue tank. Some are 25 litres, some are 10 litres. But then the only way to do it is to siphon out. It won't be too much over, it might be 1 or 2 litres over, because you've got the nozzle of the fill nozzle of the AdBlue. That can cause the issue. Paul, yes, there is issues with the saturation levels. This can be due to an AdBlue metering valve crystallizing or dribbling. Also, knock sensor failures on the later system. Yes, on the new 654, 656, there is still knock sensor issues. However, Mercedes-Benz are modifying them to be more magnesium tolerant, and this should eradicate knock sensor failures to a certain degree. Hi Damien. The engine will be able to start, it only won't start when it comes up as the engine start not possible. Once that happens, regardless of the fill level, the vehicle will not start, because it's then got to the stage where it doesn't know what the level is of the AdBlue tank, so it assumes it's depleted and it just will not allow it to start. Hi Paul, the saturation can be reset depending on engine variant. It's simply carried out as an adaptation of the AdBlue metering valve. Just to add to that, Paul, sometimes, depending on the variant, some of the later ones are password protected via Mercedes-Benz. Therefore, it would sometimes render or require an online dealer tool to carry out the adaptation. Hi Zane. Generally, the poor quality AdBlue can be, there are 2 different types. There are HGV AdBlue and there are passenger car AdBlue. You need to measure it, measure the refraction of the AdBlue, which will tell you the quality of it. But generally speaking, anything passenger car wise or available in like garages and things like that should be passenger car specific AdBlue. And it's not a very common happening that the AdBlue is poor quality. You may get a fault code saying AdBlue quality low or tampered with. This is generally when the AdBlue is running out and it's aerating, and the SCR control unit cannot allow for that, so it just sends a fault code saying AdBlue quality low. If you use a refractometer, you should be able to determine if the AdBlue is the correct quality. Paul, yes, the Zentry pass-through should have the adaptation of the metering valve. Thanks, Paul. Thanks, Mark. Thanks, Paul. I'm unsure when the next presentation is, Des. Soon, hopefully. Okay. If you've enjoyed this webinar, then please look out for the next webinars via our website, or you can access the past webinars at the Opus IVS channel. Don't hesitate to contact us if we can support you and your workshop. Thank you for watching and stay safe.